Compute the limit as n approaches infinity of the square root of n squared plus n squared plus n minus n. Okay. When you first look at this, you might think that the limit is 0, but I know for things that look like this, that's not necessarily the case. But I don't remember what the typical techniques for computing something like this are. So I might need to just manipulate this equation a little bit to see if I can come up, see if there's an equivalent expression that is a little bit easier to handle. The first thing that comes to mind is to multiply in the numerator and denominator by something like this. Don't know if this will work, but let's see what happens. So this gives n squared plus n minus n squared divided by n squared plus n root plus n. So that's if I think of that and that as separate terms, then this looks like the factorization of a difference of squares. And what do I have here? This is equal to n divided by n squared plus n under root plus n. And maybe now I can factor something out from the denominator. Probably want to factor n out from the denominator, right? So this becomes let's write this as n squared times 1 plus 1 over n under a square root plus n. So this is n divided by, here I have n, 1 plus 1 over n under a square root plus n. So n cancels everywhere. And I'm left with 1 over 1 plus 1 over n square root. And this, so these are all equal. So now as I take a limit, as n goes to infinity of this quantity, I clearly get 1. So my answer to this original expression is that this is equal to 1. I hope I did this all correctly. Let me just check quickly some of my work. All right, this times this is this. That's squared. Great. Cross terms cancel. So I have n divided by that. This is n squared plus n. Yep. Come out of the square root. N cancels everywhere. Yeah, I think this all works. So that's the answer that I'm giving, is 1. Yeah, I've seen stuff like this, of course, many times, but don't necessarily remember what the result is. And I guess it's kind of, there's only really one approach that I think is kind of reasonable here, is multiplying and dividing by, what do you call it? A rationalizing term? Something like that, I guess. And then it just all happens to work out. But yeah, if I hadn't thought of multiplying by that, I'm not sure exactly what I would have done. Yeah, and maybe there's other nice approaches to solving a question like this. But I'll let you come up with those on your own. Thanks for watching.